Hi students, now we are going to explain one of the theorems of moment of inertia, that is parallel axis theorem. So it is a theorem which relates the expression for moment of inertia of a rigid body about two parallel axes. Here the rigid body is considered to have two axes, one passing through its center of mass C and a parallel axis passing through the point O. So the axis AB passes through C, which is the center of mass. The axis DE passes through the point O, such that DE is parallel to AB and small d is a distance of separation between the two parallel axes. Okay. Now, when the axis of rotation changes, the moment of inertia of the body will certainly change. And when will the rigid body have the minimum moment of inertia? When the axis passes through the center of mass. So, when you shift the axis away from the center of mass, naturally its moment of inertia is going to increase. By how much times? That is only given by the parallel axis theorem. Okay students, fine. Now, what is I see in this picture? It represents the moment of inertia of the rigid body about an axis passing through the center of mass. IO is the moment of inertia of the rigid body about another parallel axis DE which passes through the point O. And capital M is the mass of the rigid body. And small d represents the distance of separation between the two parallel axes. So this is a small d. So then according to the parallel axis theorem, the statement goes like this. IO is equal to IC plus md square. So in words if you write means the moment of inertia of a rigid body about a given axis is equal to the sum of its moment of inertia about a parallel axis passing through the center of mass and the product of its mass and the square of the distance between the two parallel axes. Shall we prove this now? Okay. For that, let us consider that the entire rigid body is made up of or packed up of so many point massed particles. One such point mass is located at P. So its mass is small m. Like that, there are different particles which are located at different distances from the center of mass C. So I am considering a point mass of m, okay, which is located at a distance small x from the axis AB, which is passing through the point called the center of mass C. So when the entire body is rotating about the center of mass, only this particle of mass m experiences how much moment of inertia. I will get an expression for that. So moment of inertia of the point mass, okay, moment of inertia of the point mass m about the axis, about an axis, okay, passing through the center of mass, that is AB, about an axis AB. So it's equal to its own mass m into the square of its distance, that is x square. So mx square is the moment of inertia of only this particle or elementary mass or unit mass or point mass, that is denoted by m. Like this, there will be so many particles with which the rigid body is made up of. Therefore, moment of inertia, okay, therefore, moment of inertia of the entire rigid body, about, okay, about the axis, AB, which is passing through the center of mass, must be equal to sigma mx square, that is equal to IC. Okay students, so sigma mx square means what? It is the algebraic sum of all the products of the mass of the particles and the square of the distances of those particles from the given axis AB. Have you understood? Therefore, in this IC, okay, represents sigma mx square. Okay, this can be called as equation 1. Now, what is the moment of inertia of the same particle, okay, of mass m about some other axis DE, which is at a distance of small d from AB. So when I consider the same particle from the second axis DE, its distance is x plus d. Is it not? So I will write moment of inertia of the point mass m about another axis, okay, about the axis DE, okay, DE. This is equal to mass into distance square. So since the point mass is at a distance x plus d, this is x plus d the whole square. Okay, students. So this is equal to m into x square plus d square plus 2xd. Therefore, its moment of inertia, that is moment of inertia of the entire rigid body, as a total rigid body about the same axis. Okay, students, about the axis DE, about the axis DE is equal to sigma m into x square plus d square plus 2xd. So this can be denoted by the symbol IO. So here IO means what? Moment of inertia of the rigid body about a parallel axis, that is DE. Okay, students, therefore I naught or IO must be equal to sigma m into x square plus d square plus 2xd. So how many terms are there in the bracket? You see, there are 3 terms. So I am going to separate them into 3 summation terms. So this is equal to sigma m x square plus sigma m d square plus sigma m into 2xd. So this is once again written as sigma m x square plus sigma m into d square plus this 2d I will take out into sigma m into x. Okay, fine, students. Now you look at the right hand side of this equation. The first term is sigma mx square. Okay. So from the first equation, is it also equal to IC? Is it not? Okay. So I will write. So this is equal to IC, which is the moment of inertia of the body, okay, about the axis AB passing through the center of mass. Next, if small m is the mass of a single point particle, then what will be sigma m? That will be equal to the total mass of the rigid body. So already we have mentioned here what is capital M. Capital M is the mass of the rigid body. That is nothing but equal to what? Sigma m. So instead of sigma m, I am going to substitute capital M. So this is equal to capital M for sigma m. Remaining term is what? Okay. So this is IC plus m into d square plus. What is the third term, my dear students? It is 2d multiplied by sigma m into x. You see here, m is the mass of the point particle and it is at a distance of x. M into x for this particle you take, since x is on the right hand side of the axis, mx will be positive. Equally, at the same distance, on the left hand side, there will be another similar particle of the same mass m. For that, the x coordinate is minus. Since we have considered the axis AB passing through the center of mass, if you take the product of m into x for all the particles on the right side of the axis AB, they will be positive. Similarly, if you take the product of m into x for all the particles on the left side of the axis AB, that will be negative because x coordinate is negative. Therefore, naturally, if you add the product of m into x for all the particles, the algebraic sum of this m into x must be equal to 0 because that is the axis passing through the center of mass. About the center of mass, if you take the product of m into x for all the particles on both sides of the axis AB, then the sigma mx will be equal to 0. Therefore, this is the third term will be 0. Therefore, are we getting now? I naught is equal to IC plus md square. So, we have proved that the moment of inertia of a rigid body about any axis is equal to the sum of its moment of inertia about a parallel axis passing through the center of mass. And what? The product of its mass and the square of the distance between the two parallel axes. Have you understood, students? Okay, now we will go to the next theorem.